Our second example for the case A is 3 by 3 matrix is this one. We need to solve this differential equations. X prime equal to AX. So X prime equal to A times X. X prime is a vector of function at X1, X2, X3, In this case, we consider where we have one real and two complex. So the real one is lambda 1 equal to 0. Correspond to that, we have v1. For the conjugate of 1, we have the pairs lambda and lambda bar. So 2 plus 3i and 2 minus 3i. We just need to pick one of them. For example, if we pick lambda 2, then the other one is conjugate of lambda 2 and conjugate of v2. That will give us the last pairs of eigenvalues and eigenvectors. For the first eigenvalues, lambda 1 and eigenvectors v1, we have the eigenfunction v1 with lambda 1 as we have known before. For the other pairs lambda 2 and v2, now we form the eigenfunction f2d, and we will separate that to have the real part and the imaginary part. And these two real and imaginary parts will give us two real functions, and these two functions together with this one give us the linear combination, give us the general solution. So let's do this example where we have lambda 2 and v2 here. Function f2d will be v2 e lambda 2d 1 plus I minus 2 e 2 3 I d. So v e lambda d 1 I minus 2 e 2d e 3 I 3d. Now using the Euler formula, e I theta cosine theta I sine theta, or theta is 3d. E 2d is out there. Inside you have 1 I minus 2 cosine theta 3d I sine 3d. Multiply that inside the vector. Cosine 3d I square minus 1 sine 3d I cosine 3d I sine 3d. What I did was I just want to get the real part first. So the real parts come from this one and this one plus this one times this one. Cosine 3d plus I square sine 3d. So I square minus 1, that's why we have this. Imaginary parts come from this pair and this pair. The other two is a lot easier. Minus 2 cosine 3d plus I times minus 2 real part. This is real part, and this is imaginary. Of course, we need to remember this one. So we have the real part of ft, which is this one. Imaginary part of ft still e to t multiply these vectors. Remember the signs of I. So we have this one is minus here. Minus. So these two will give us two functions. And then combination of these two and the one we have from V1, we get the general solution. General solution of the original one. Let's say x prime equal to ax is of the form coefficient or scalar C1 times V1 is lambda 1t. V1 lambda 1 is 0. It was the same for lambda 1 even non-zero. C1 E V1 E lambda 1t. So 0t is equal to 0. E power 0 is 1. C2 times the second one. And C3 times the last one. So this is the general solution for the case where the complex eigenvalues appears.